All right, so we're going to look at building stem and leaf plots again, and we're actually going to use this data set from 1.35 in the text. If you don't have that text, what it is, it's a data table, and it is comparing nurses per 100,000 of people by state, and this is alphabetical is the way this is entered in for all 51 states. Wait, we only have 50, right? So it's also including District of Columbia, which is the very last one. Puerto Rico is not in the list for some reason, but hey, whatever. It is. It probably should be in the list, but that's neither here nor there. So the first thing we're going to want to do when we build the stem and leaf plot is we're going to want to clean this data a little bit. And cleaning data is an aspect of statistics. Some people think, well, when you clean data or you scrub the data, it means you're doing something bad. No, it doesn't mean that. It can be that if you don't do it correctly, but for our purposes, it's not at all what we're doing here. When I look at this data, we're dealing with some rather large numbers here. So to make this process easier, when we identify our stems and our leaves, we want to fix that. One thing you could do is say, well, I'm going to make the stems or the leaves just the last digit. So just in here for 911, it'd be just the 1, and the stem would be 91. Well, you can see how many stems we'd have if we did that, a lot more than is really useful to us. So what we're going to do is I'm going to make the stem be the 9 and the leaf be the second digit, which means that the third digit here is not terribly useful to us. So one of the ways I'm going to deal with that is I'm going to click on that next column there. I'm just set equals. I'm going to take this value right here and I'm going to divide by 10. And when I do that, I get 9.1. And then right here, I'm going to tell it, well, I want it to round. And I just type in round. And I'm going to click on the cell I want it to round. And then I'm going to tell it what digit I want it to round to, which in this case would just be the first digit, which I'm just going to put a 0 in for that. Okay, there are lots of ways you make it round, but this is for our purposes. Now, I don't have to retype that every single time. I can highlight those pieces. Control C to copy them, and then I'm just going to go down this column all the way to the very last value and do that for all the values there. And you can see that these last two here, I overwent it and just delete those out. So now I have it listed out. Okay, so now I have all this set up, but now the data is the wrong value. So what I'm then going to do is I can then reset this value. If I wanted to do this, I could reset this and make this equal to this value times 10, and then it's back to the correct sizes here. Not really necessary for us to do that, but we can if we want to. Column C will work just fine for us. All right. So now what I want to do so we don't need to do that here with this piece. So now what we're going to do is we have the stem being 9, the leaf would be 1, the stem would be 7, the leaf would be 2, and on down the line all the way through there. So to create the stem and leaf plot for this, the first thing I want to do is we're going to order these. So I'm going to click the column there, and then I want to order them from least to greatest. So I'm going to go over here to sort. I'm going to sort from smallest to largest and expand the section. Yeah, sure, we can expand the section. And it doesn't really matter the first two columns what they look like. What's really concerning is what that last column does. So what I did is I ran through and I rounded the values first, and then once I had the values rounded, I then could get rid of that last digit and just make it easier to look at. So that's all I'm doing here is just making the values easier to look at and not dealing with the rounding. Like 585 is now 59. That's just easier for me to do this, less processing. And then over here, I'm just going to go through and list all of my stems. So 5, 6, 7, 8, 9, 10. And let's see, what else do I got? 10. Do I have 11? Yes, I have 11. Okay, so 11. And then if you look here, I have 12, I have 13, 14, and then 83 apparently, which is a lot. So there may be something wrong with that little piece right there. I'm not sure what's going on with that. 8,000, that may be the total. That's a big number. I must have mistyped that somewhere. So this is another aspect of cleaning, is that when you do this process, you come across, yeah, so I found that value and I have an extra 4 in there. So that should be that. Now in there, we changed it in real time. So what I'm going to do here is I'm just going to resort that again. Yes, sort the whole thing. And then there we go. Now we got it set. So we got 11, we got 12, 13, and 14. So 12, 13, 14. So there are my stems there. And then my leaves, I'm just going to go by the ones digits, which is 9 for the 5. That's the only 5 I have. And then 1. And then I'm going to tab over and I can type in my next value, which is a 1. And then my next value, which is a 3. And then a 4. And then a 7. An 8. A second 8. And a 9. And then we're just going to go through and do this for all the values as we go through there. All right, so the 7, the stem 7, I now have 2, 4, 6, and then 8, I have 0, 0, 1, 1, 3, 3, 5, 5, 6, 6, 8, 9. See here, sir, my 9s, I have 2 zeros. 1s, I have 1, 2, 3 1s. 3, 4, 3 5s. 7, and an 8. All right, and then 10. I'm almost off my screen there, huh? So the 10 I have still. Now this is where you have to pay attention. The 10 is the stem, so the first 2 digits are my stem. That last digit is my leaf, so that's going to be 0. I have a 1, 2, 2, 2, so 0, 1, 2, 2, 2, and then 3, 4, 5, 3, 4, oops, 4, 5. Pardon me. And then 9 and 9. And then I'm on to my next leaf. And I have 1 10 and 1 16, so that is 0 and 6. And I got 12, which is all by itself with 6. 13, which is 0, and then 14, which has an 8 to it. And there's my stem and leaf plot. It gives me nice, clean results. I can look at this and see that this is what we call fairly normal looking, meaning that it has a single peak in the middle-ish. It may be skewed a little bit right. You'd have to kind of turn it sideways to see that, but we can still talk about this. If we were to build a histogram for this, we'd also do that. And you can kind of compare how this relates to the histogram. This is fairly quickly. To do this in this format here, we just go to click to insert, and then we can click the second piece right here. Here are my histograms. And well, I didn't tell it what values I wanted to do there, so let me do that for a second. So 14, I lost my value there. So that's 8 for the 14. So I need to do this column. I'm going to do insert. I'm going to do a histogram, and there's my chart. I can move it kind of out of the way. And if you look at that chart is more or less the same shape as my stem and leaf plot. You can see the different columns, and we can reset these columns to different values as well, but for the most part they're pretty consistent with what I'm looking at here. The advantage of looking at the stem and leaf plot is it's very easy to do this by hand. We didn't really do anything technical with this process. You can do all the stem and leaf plot without doing columns B and C, and you could have just done column A with it and just done the rounding as you went. But now you can tell that it's a little bit, it looks fairly normal. It is right skewed. And then also we can answer questions about this. Like, for instance, do you think it'd be useful to split the stems in a different way? One of the questions, if you look at this, is from question 1.35. Do you think it would be useful to split the stems when you're drawing the stem and leaf plot for this data? Like, well, apparently it looks like it's fairly useful because it kind of gives us a pretty good idea of what we're dealing with. Keep in mind also that when we look at these, because this is a question I get from time to time, is like, well, right here it says 130. So does that mean that there isn't anything in the 13 column? Yes, there was. It was 130 was what that value was. So there's that piece of it. Now we can start talking about the implications of what this data tells us. Where's the mean? Where's the median? Where's most of the data at? Something half of below and half of it above that value. We can even look at that here when we talk about, we know there's 51 values here, so we're talking about it being right at the 26, 25 mark. So 90, half of the data lies above, and half the data lies below 90. So right here is that mark. If we want to just kind of color that for a second. So half of the data lies above that mark, half the data lies below that mark, which is kind of interesting and useful. The fact that you have one group over here with almost 150 nurses per 100,000 people, does that state have better medical care than this one over here that has 59? Actually, I guess it was 590, and this is 1,480. Do these two places have significantly different medical care? For instance, this 590 or 585 is actually the number, was Arizona, versus 1480, which was the District of Columbia, which is very interesting when you think about that. Why would the District of Columbia have that many nurses? And it was kind of an outlier. If you think about these three pieces right here, you have the 12, the 13, and the 14. That's 1,200, 1,300, and 1,400 nurses per 100,000 people. Are those outliers indicative of something else that's going on? The 1,300 was South Dakota. That's a lot. I'm surprised by that. I don't know if you are or not, but I'm surprised by that. The 1,200 was Massachusetts, which I always feel like I say wrong. And then that was the 1,300, pardon me. The 1,200 was Delaware. Well, a couple of those pieces make sense, but South Dakota, really? It's a very low populated state, and it's in the middle of the Midwest. Who lives there? Apparently only nurses. So there's a lot of questions that we can start to ask, and then a lot of questions that we can start to investigate and find more information about when we start dealing with this, because these outliers are now telling us, wow, there's really nothing else over here with these pieces. Why would the District of Columbia have so much? Where's the norm? These states that are right here in the center, do they have fairly typical health care in relation to each other? 900 seems to be kind of the median number of nurses per 100,000 patients. How did these patients, what do these states look like under normal circumstances? What do they look like during a pandemic over the last few years? What difference did that make in the quality of care? There's all sorts of questions that we can start to dig in on and ask more and answer more things about just simply by using this as a starting off point. So again, building the stem and leaf plot is a fundamental aspect of building and understanding what's going on with the data, but it's not the end-all be-all. There are other things that we now know that we need to go ask more questions about. All right, more videos to come. Enjoy math, all right?